Hi there. In the last part, we have seen how to decouple various application components using Amazon SQS. In this part, we are going to build the image moderation workflow using step functions and Amazon Rekognition. By the end of this video, you will have an end-to-end working application for image moderation. So the services that we are going to touch in this part are going to be AWS Lambda, step functions, SQS, Amazon Rekognition to analyze the image, simple email service to send the emails out to the users or to the administrators, DynamoDB, and IAM. Okay, so let's take a look at our architecture diagram to see where we are in building this application. So we have done until this part where we are creating an SQS message when an image is uploaded from the user, and that message is residing in our image moderation queue. In this part, we are going to build everything that is on the right side of this SQS queue. So the first thing that we are going to build is we are going to trigger one of our Lambda functions, the start image workflow, when a message arrives in our SQS queue. This Lambda function will in turn kickstart our image moderation workflow, which will be a step function. And it will have a series of Lambda functions to do very specific tasks. So the first Lambda function, which is analyze image labels, will send the image to Amazon Rekognition and get the labels back, which will in turn say what this image contains. The second Lambda function will store those labels in our DynamoDB table. So remember, we have created an entry in our DynamoDB table, a record for our upload. So it will augment that record with the image labels. The third Lambda function, this is where the decision making will happen, move image to prefix. So if the image contains any restricted categories, then it will move that image to a review prefix, indicating that this image requires further review. And if the image doesn't contain any restricted categories, then it will move this image to an approved prefix, so indicating that no further review is necessary. Then we will send out the emails. So remember, as per our requirements, we need to send the email to the user if their submission is live. And also if the submission requires further review, so if Rekognition detects that the image contains any restricted categories, in that case, we are going to send two emails out. One is to the user saying that their submission is under review. And the second one is to the administrators, the platform administrators, to indicate that they need to review one of the image or one of the submission that has come in from the user. So this Lambda function will send those emails out using AWS SES. And finally, we will have the last Lambda function, which will essentially just mark the upload complete. So to be honest, there is no need for these many Lambda functions. We can certainly combine some of these Lambda functions together. The reason I wanted to do that is to show the capabilities of building workflows using step functions. All right, let's get started and build our first Lambda function, which is going to be start image workflow, which will get triggered when a message arrives in our SQS queue. All right, so I'm logged into my AWS management account. So let's create the Lambda function to start the image moderation workflow. So let's go to Lambda and create function. The function name is going to be start image workflow and the runtime is going to be Python, and I'm going to create it. The function is now created. Remember, this function is going to get triggered when a message arrives in the SQS queue. And in order to do that, this start image workflow Lambda function needs to have proper permissions on that SQS queue. So let's provide those permissions first before we do anything else. So let's go to configuration and permissions. And as of now, it has only permissions for the CloudWatch logs. So let's add the permissions to retrieve the information from our SQS queue. So click on the execution role. It will open up in a new tab. And let's add an inline policy. The service is going to be SQS and the actions allowed. So from the read access level, we need get queue attributes permission. So in order for the Lambda function to read the message from the SQS queue, it needs to poll that SQS queue. And in order to poll the SQS queue, it needs this get queue attributes. It needs to know what the queue attributes are. We also need the receive message permission. So it needs to read the actual message within the SQS queue. So receive message is what we need. And from the write access level, we need the change message visibility permission. So why it is needed? When a Lambda function reads a message from the SQS queue, and while it is processing that message, it needs to change that visibility of that message so that other Lambda processes wouldn't pick that message up. So it is a temporary changing the visibility of the message. The message is still in SQS queue, but it is not visible to other processes. And that is important because we do not want the same message in the SQS queue being taken up by multiple processes. And then we also need a delete message permission. So once Lambda finishes processing the message, it should be able to remove that message from the SQS queue. And in order to do that, it needs this delete message permission. Okay, scrolling down from the resources tab, we need to specify the ARN for the SQS queue. So let me open up a new tab and let's go to SQS and let's copy the ARN and come back to our policy, click on add ARNs and paste the ARN and click on next, and let's provide the policy name and create the policy. Okay, so this Lambda function start image workflow now has the required permissions to get the information from our SQS queue. I'm going to close this execution role tab and on our Lambda function. So remember, this Lambda function needs to get triggered when the message arrives in the SQS queue. So let's add that trigger. So from the function overview widget, click on add trigger. And for the source, let's say SQS. And then it will ask you to enter the ARN of the SQS queue. But if you click inside this text box, it will list all the SQS queues that the account has. In this case, there is only one. So select image moderation queue and it will populate its ARN. And I'm going to change the batch size to 1. So the batch size specifies how many messages that a Lambda can read from the SQS queue. So by the default value is 10. So it means that whenever a Lambda is invoked, it can read up to 10 messages from the SQS queue. In order to keep things simple, I'm going to change that to 1. So anytime this start image workflow Lambda function is triggered, it will read only one message from the SQS queue. And I'm going to click on add. Okay, so now the trigger has been successfully added. All right, so let's add the code for this Lambda function. But before we do that, let's add a couple of environment variables. So we are already on the configuration tab. So let's go to environment variables, edit, and add environment variable. So the first variable I'm going to add is S3 bucket name. So this is going to be the bucket name where the user uploaded images would reside. So let me go open up a new tab, go to S3, and this is the bucket uploaded images. And I'm going to copy this and I'll put it as the value. Another environment variable that I'm going to add is called state machine ARN. And I'm going to keep the value for it as blank for now. So going back to our architecture diagram, this start image workflow Lambda function needs to invoke this image moderation workflow step function. And in order to do that, it needs the ARN of this step function. So that ARN will be put in this environment variable here. And I'm going to add another environment variable. It is called DDB table name. So this is the name of the DynamoDB table. Again, going back to our architecture diagram, start image workflow is going to update that record in the DynamoDB table to indicate the processing of the image has started. So we are going to specify the DynamoDB table name in there. So I'm going to copy the name. So I'm just going to open up a new tab and go to DynamoDB tables. And this is the table name, image upload requests. So I'm going to specify that and I'm going to save it. Okay, so now the environment variables are added. Let's go to code and I'll make it into full screen. And let's start by importing the required libraries. So import Boto3, import OS. And let's create a client for our step function. So we should say, we can say sfn equals boto3.client step functions. Okay. And in the Lambda handler, let's first read the environment variables. So we can say s3 bucket name equals and state machine ARN, we are reading it. And let's read the DynamoDB table. So DDB table name All right, so let's quickly add a few of the validations to make sure that we have the required S3 bucket name and the state machine ARN. Let's say if not S3 bucket name, I'm going to say raise exception, S3 bucket name not defined. And if not state machine, raise exception, state machine ARN is not defined. I'm not going to do anything for the DynamoDB table just yet. And now let's start processing the message that we get from the SQS queue. And that message will be present in the events parameter here. Now, if you remember, we specified the batch size as 1. So that means this event parameter will only have one message. But as a best practice, we should actually loop through the records in the event parameters so that, in future, if we change the batch size to, let's say, 5 or 10, the code wouldn't need to be modified. So let's read that in a loop. So we can say for record in event.get records, and we say body equals record.get body. So remember, this body is going to be a JSON object because that is how we are putting the information in the SQS queue. And as part of this function, we are going to build a payload that it is going to pass through the image moderation workflow step function. So let's build that payload. So coming back to our Lambda, we can say try payload is equal to json.loads body, except now it should not happen, but let's say by any reason, if the message in the SQS queue is corrupted, it's not a valid JSON object, we will convert that into a JSON object. So we can say JSON decode error. We will say invalid JSON in the message body, but then we will change the payload to be a JSON object. We can say raw body. And then we will augment this payload parameter with the S3 bucket name. So we can say something like payload bucket equals, and we have read the S3 bucket name here. So I'm going to copy this. Okay, so now we have built most of the payload that we are going to send to the step function. So let's create that step function now. So couple of things that we'll need to do. So I'm going to close the tabs first. So coming back to our architecture diagram, this step function is going to orchestrate the image moderation workflow. And as part of that orchestration, the first thing that it is going to do is to call analyze image labels lambda function. So let me create this analyze image labels lambda function. So I'm just going to say create function, and function name is going to be analyze image labels. Runtime is Python. Create function. The function is now created, and all I'm going to do in this function for now is in the lambda handler, I'm just going to print the event parameter that it is receiving, and that's about it. And you will see why. So let me deploy this first. And I'm going to close this analyze image labels lambda function tab here. I'm going to open another tab, and I'm going to go to step functions and click on get started. So by default, it will give you some options to run a predefined hello world orchestration or choosing a template. In this case, I'm going to click on create your own, and my state machine name is going to be image moderation workflow, and let's say continue. And now you see a design studio where you see a start and end, and we can design the workflow in between the start and end steps. So remember, the first step in the image moderation workflow is analyze image labels lambda, and that is why we created it, although it is not doing anything other than printing the event parameter. So let's go back to our design workflow, and from the left hand side, drag AWS Lambda invoke. So what does this mean? So it means that when the execution of this step function will begin, the first thing that it is going to do is to invoke a Lambda function. And which Lambda function it is going to invoke? So if you click on this, on the right hand side configuration one, Lambda invoke configuration, you can go to API arguments and select the function name in there. So the first function that is going to call is analyze image labels. So we can select that from the drop down, and let's say create. So it will create an execution role as well with full permissions, and that's fine. Let's say confirm. So our state machine is successfully created. Now coming back to start image workflow, Let's write the code to invoke the execution of this step function or state machine. So if you look at the state machine executions right now, there are no executions. You refresh it, no executions. So we need to specify a name for it. And the best way to do it is to use UUID that we already created for the image upload. So we can use UUID as the name, as a distinct name for each execution. So coming back, we can say exec name equals payload.get. And remember, the payload has the upload ID. This is how we created the message in the SQS queue, and that will be the execution name. Okay, so now let's build the quarks for the execution of the step function. So we can say quarks equals, and Amazon Q has given us the suggestions. It needs the state machine ARN, which we are reading from the environment variable. It is going to need the name for the execution, which is the exec name, which is essentially the payload or the upload ID, and the input is going to be the payload. Perfect. So let's execute the step function. So we can say sfn dot start execution with the quarks that we have built here. Perfect. And I'm just going to say here return. It doesn't really matter here. We can say status code of 200, and we can say body. We can just say image workflow started. And between the execution of the step function and the return, I'm going to add the code to update the DynamoDB. So you can say add code to update DynamoDB record. So again, coming back to our architecture, this function is doing two operations. One is to, or rather three operations. One is to poll the SQS queue, read the message, start the image moderation workflow step function, and then update the upload record, indicating that the processing has started. So this is the first part of our processing workflow. Okay, so let's go back to our start image workflow function. Let's deploy it. And let's go to configuration, environment variable. So remember, we kept this state machine ARN as blank, but now that we have created the state machine, we can put the ARN in here. So we have the state machine open here. So we can just copy the ARN of the image moderation workflow step function. And let me paste it here and save it. Okay. So now we need to give the permissions to this Lambda function on the step function so that it can start execution. So this operation requires permission to be provided to our Lambda function. So let's go to configuration, permissions. And right now it has two, CloudWatch logs and SQS. So let's add one more. So click on the role name and open up in a new tab, create inline policy, and the service now is step functions. And what access level it is going to need? It needs a write access level to say start execution. And what resource it needs that permission on? So we have copied it. I'm just going to copy it again. And I'm going to add the ARN of our step function or state machine and click on add ARNs. So once the policy is created, This start image workflow Lambda function will have the start execution privilege on this image moderation workflow, which is a state machine. So click on next and let's provide the name for this policy and let's create the policy. Right, so I'm going to close this execution role tab, open here. Now coming back to start image workflow, now it has permissions for the step function. Okay, so let's test it out. So let's upload an image through our front end. It will go to our S3 bucket, which will create a message in the SQS queue. This part we have already tested. If you go back to the previous video in the series, we have tested that. So once the message is created in the SQS queue, it will now trigger this start image workflow Lambda function, which will read that message and invoke the image moderation workflow step function. And what this image moderation workflow step function is going to do, it is going to invoke a Lambda function called as analyze image labels, and that analyze image labels is simply printing the event parameter in the CloudWatch logs. So we should expect the information about the image that we have uploaded in the CloudWatch logs of this analyze image labels Lambda function. So let's see if it is working before doing anything further. So let's go to our website and let's say name and let's say scott@gmail.com. We have not integrated any email components in our system, so it is not sending any emails out. So it doesn't matter whether this email is valid or not. And for the file, I'm going to choose this image of New York skyline and I'm going to say upload. The file upload is successful. So let's go to our state machine and see if we can see the execution. So let's go here. And we already see an execution. So if you click on this, you will see Lambda invoke. And if you click on Lambda invoke, you will see the state input. So this is the SQS message that was created. And remember, we augmented that with the bucket information in our start image workflow. So if you see here, we added this step payload bucket as S3 bucket name, and we do see that present in the state input. And now if we go to analyze image labels Lambda function, so let me open that and let's go to monitor and click on view CloudWatch logs, and let's open up the CloudWatch log here. And this is the event parameter that we are receiving. So let me copy that and I'm going to paste it in analyze image labels Lambda just to have a reference when we start building the code for it. I'm just going to deploy it for now. Okay. Now, remember we added the placeholder for updating the DynamoDB table. So let's do that now. So let's create the resource for our DynamoDB. Okay, and coming down to our code to upload the DynamoDB table, let's create a table object. So you can say table is DDB table name. Let's update the record in the table. So we can say response, and Amazon Q has given auto suggestion here. So table.update item, where the key is going to be upload underscore ID, which is exec name. So let me first check whether our DynamoDB table has this partition key. So I'm going to open up a new tab, go to that DynamoDB, tables, image upload request, and partition key is indeed upload_id or lowercase. So good there. And the update expression is going to be different. So we are not updating the S3 key or anything. We are updating the status of that record to indicate the processing has started. So we can say, remove this, we can say set status equals status. And remember, we need this hash sign because status is a reserved keyword. And now we need expression attribute names. So status is what column name within our DynamoDB table? It is status. And the expression attribute values, which is this, and what value it is going to be, we are going to just say processing started. Okay. I'm just going to print the response so that we will have that in the CloudWatch logs if we need to do any troubleshooting. And that's about it. So let me deploy this Lambda. Okay, now the function is deployed. We do need to specify the permissions for this Lambda function to update records in the DynamoDB table. So let's do that now. So let's go to configuration, permissions, and open up the execution rule, create inline policy, and service now is DynamoDB. And what actions we are allowing? We are allowing update item permission, and on what table we are allowing it. So we need to add the ARN. So let me go back to our DynamoDB table, and let me copy the ARN, and let me add that ARN here. Okay, so once the policy is created, the start image workflow Lambda function will have update item privilege on this image upload request DynamoDB table. So click on next and provide the policy name and create policy. Okay, so the policy is now created. I'm going to close this and I'm going to refresh the execution rule of the Lambda function, and I do see DynamoDB in there. So all seems to be in good order. All right, so let's do a quick test. So we will upload an image to the front end, and based on the plumbing that we have done so far, it will trigger up the workflow. And in the DynamoDB table, we should see a record for that upload, and the status should be processing started, or rather processing underscore started. Okay, so let's go to our front end and upload an image. And I'm going to select this soccer.jpg file. It doesn't really matter because we are not analyzing any images of now. So I'm just going to upload it. And I expect that in our DynamoDB table, we will see the information of this upload, and the status of that record should be processing underscore started. So let's go to our DynamoDB table and let's see, refresh, and yes. So as you can see, this was the one that we uploaded, soccer.jpg, and the status is now processing started. So everything looks good here. So we have completed coding and configuration of this start image workflow Lambda function. We have already seen that it is invoking the analyze image labels Lambda, and we also saw the event parameter that it is getting. So it is getting the entire SQS message along with the S3 bucket name. So next thing that we are going to do is to modify the analyze image label Lambda function to call recognition and get the image labels back. So this is really the essence of our application, to automatically analyze the images and see what they contain. So let's do that now. Okay, so let's make it full screen and let's import Boto3. And let's create client for recognition. Recognition is equal to boto3.client recognition. And now let's write the code in the Lambda handler. So the event parameter of this Lambda handler will have an object coming in this format. So this is what we have seen, what we built with the start image workflow Lambda. It is going to send it in this format. And let's start by reading the bucket name. So bucket is going to be event and bucket. So it will read the bucket name from here. And let's read the key is event and S3 object key. So now our Lambda function has information about the bucket and also the event key. Now let's call recognition and get the image labels back. So Amazon Q has auto-completed this. So let's say response is equal to recognition.detect labels, and it is passing the information about the image. So the S3 object has the bucket name and also the S3 object key. So max labels are 10, so it can return up to 10 labels in that image. And I'm going to print this response. And the labels, I'm going to read that from the response. Response is equal to labels is equal to response dot get and labels. And what this Lambda is going to return. So every Lambda in this workflow is going to feed to the next Lambda. So analyze image labels is going to feed store image labels. Store image label is going to feed move image to prefix Lambda, so on and so forth. So what information we want analyze image labels to send it to store image labels. So I'm going to pass the entire payload that analyze image labels received from start image workflow, and I'm also going to add the labels that the recognition has returned back to analyze image labels. So that's going to be the return code or the return object for this Lambda. So return, and I'm going to say bucket, and bucket is in this bucket variable, and then I'm going to say S3 object key, which is key. Then labels we are returning that we have received from Amazon Rekognition, and then I'm going to send the same information again. So username is event username, and user email. It's event user email and S3 file name. Perfect. And finally the upload ID. Perfect. So this is going to be the return object from this Lambda function. So let me deploy this Lambda. The Lambda is now deployed. Now we have to think about the permissions. So this analyze image label is doing two jobs. It is getting the image from our S3 bucket, so it needs permission for that. And then it is calling Amazon Rekognition, and it is asking Amazon Rekognition to detect labels. So it needs permission for detect label. Okay, so let's configure these permissions one by one. So let's go to configuration, permissions. And as you can see right now, it only has permission for CloudWatch logs. So let's click on the execution role name and let's say add inline policy. First, we will do S3. So let's select the service as S3. And what permission it is going to need? It is going to need get object permission so that it can read that image from our S3 bucket. And here is get object. And resource. So what resource are we going to provide this permission on? That will be our S3 bucket. So I'm going to open up a new tab, S3. And this is the bucket where the uploaded images are getting stored. So I'm going to go in properties and I'm going to copy the ARN and add ARN. And now remember, it needs access to all objects within this bucket. So I'm going to put a / and a star so that it can read any object in that bucket. And I'm going to click on add ARN. So click on next, and we will provide the policy name. And let's create the policy. Okay, so the S3 permission is now created. Now let's add permissions for recognition. So same thing, add permissions, create inline policy. The service is going to be recognition. And for the actions, if you go to read, we are looking for detect labels. But as you can see, there are plenty of things in here, really interesting. So it has list faces, search faces, detect faces, get celebrity information. So I would highly recommend you to go and play with it and see what type of responses that you get depending on whatever image that you're uploading. But for now, for our purpose, we need the detect label permission, so that we have selected. We don't need to select any resource because recognition is a service. And let's go to next and create the policy name. And let's create the policy. Okay, so the S3 policy has been added, recognition policy has been added. I'm just going to go back to our analyze image labels, and I'm going to refresh the execution role just to make sure everything is fine where it is. And now let's do a quick test. So this is the image that I'm going to upload. As you can see, it's a skyline of New York City, and there are plenty of things happening here. Obviously, it's a cityscape, it's a skyline. We see plenty of buildings, but we also see some construction cranes. So we see one construction crane here, the other one here, there's one more here. It will be interesting to see if recognition identifies that. There is also Brooklyn Bridge in the foreground, and there is also a freeway with cars on it. Now it will be interesting again to see if recognition identifies these dots as cars. Maybe not. Let's see. So let's upload this image and see what labels recognition returns back. Okay, so let's go to the website and let's add the names. And I will choose that New York skyline. This is the image. And let's say upload. So uploading is successful. Now let's go to our step function. And this is the execution. So let's click on that. And if you click on the Lambda invoke, this is the function, this is the analyze image labels step within the workflow. You will see the state input. So this is what the analyze image labels got as an input. And this is the output. So let's look at the output. That will be interesting now. So as you can see, the labels that recognition has returned. So there is obviously architecture with very high probability confidence. There's buildings, obviously, yes, very high confidence again. Cityscape, then it has urban, city, okay. Outdoors, all right, that's all right. There's bridge, so the Brooklyn Bridge in the foreground, a very high confidence rating for that as well, so that's good. Construction crane. We saw a few of the construction cranes in the picture. It's great that Rekognition has identified that. The bounding box object, which has the width, height, left and top, that shows the area within the image where it found that particular category, in this case, which is construction crane. All right, so let's now develop the second step of this workflow, which is store image labels. Now this function will get the information about the image labels from analyze image labels function, and it will simply store that in the DynamoDB table. So okay, so let's create the store image labels function. I'm going to go to functions in Lambda, and I'm going to create a function. So the function name is going to be store image labels. Runtime is Python, and let's create this function. All right, the function is created now. So remember, this function needs to update the DynamoDB record for our upload process and update that with the labels that it has received. So let's first add the required permissions. So let's go to configuration, permissions, and open up the execution role. And let's add an inline policy. So service is going to be DynamoDB. And the action is going to be under write. It is going to be update item. And the resource, so we need the ARN for our DynamoDB table. So we already have that open in a tab. So let's go to tables and copy the ARN. And let's add that ARN here. And let's give a name for our policy. And let's create the policy. All right, the policy is now created. Now the store image Lambda functions has the required permissions to update items in the DynamoDB table, which is the image upload request table. So I'm going to close this execution role tab here and come back to store image labels. And let's add an environment variable here, which is going to be the DynamoDB table name. So let's go to environment variable under configuration and edit. And let's say DDB table name. And the table name is image underscore upload underscore requests. I'm going to add that, make sure there are no spaces, and I'm going to save it. Okay, now let's go to code. I'll make it a full screen. And let's start by importing the required libraries. So let's say import Boto3, import OS. And let's import, we say from decimal, import decimal. So the confidence rating, we need to store that in DynamoDB table as well. So that is in the decimal format. All right, so let's create the resource for our DynamoDB. So we say DynamoDB boto3.resource DynamoDB, perfect. And let's go to Lambda handler. The first thing that we'll do is let's read the table name. So we say DDB table name is equal to OS. And let's create a table object. Table equals DynamoDB table DDB table name. Now remember, this Lambda handler for store image labels will get the output of analyze image labels, so as input. So the object that we see in the state output for analyze image label will be the input for the store image labels. So first let's read the upload ID from events. So we can say event.get upload ID, and let's get the labels equal event.get labels. Let's see what's the exact name. Labels. Perfect. Now remember, the labels, what we will get will be this entire object from here, and it has little bit more information than what we want to store in the DynamoDB. Now all the information is good, but to keep the things simple, I'm going to store only name, confidence, and categories in the DynamoDB table. So let's simplify the labels. So what we can do is we can create a function to simplify that. We can say something like simplified labels is equal to and we will pass the labels to it. So let's create this function. So we say def simplify labels and labels. So Amazon Q has auto completed it. I don't want instance or parents, but I do want category. So I'm going to remove these two. And I'm going to add the categories. Label dot get categories, or if it is not present, just an empty div. So let's quickly take a look. Categories, perfect. And all it will do is after that it will return those simple labels. Okay, so now we have all the information that we need. So let's update our table. So table.update item, key is upload ID, which is upload underscore ID. Update expression, set labels equals labels. And also let's update the status. So let's do status equals status, and let's say expression attribute name status is status, and I think the status is with the capital S. So let me go back to DynamoDB and let's see how we are storing the status. Yeah, it's a capital S, so I'll modify that. And the expression attribute values, so labels will have simplified labels, that's perfect. And for the status, I am going to say labels stored. Okay, so let's deploy this Lambda and let's do another test. The Lambda is now deployed. Now we do want to make sure that this Lambda is designed to be in the workflow. So let's go to our step function. which is image moderation workflow. And let's click on edit. And now in this design studio, let's drag another AWS Lambda invoke and place it between the first step and the end step. So again, we'll have to do the same thing. So it is going to invoke this Lambda first, which is the analyze image labels. And after that, it is going to invoke another Lambda. And for that, we have to specify what that Lambda function would be. So again, in the function name, we can say store image labels. And let's save it. And let's say confirm. Okay, so now our workflow is consisting of two steps. Step one is to analyze image labels. And once that is finished, it will invoke the second Lambda, which is store image labels, which will update the image record in the DynamoDB table with the labels that are returned by Amazon Rekognition. All right, so let's do a quick test. So we will again upload an image and we will see what kind of information is stored in the DynamoDB table. Okay, so I'm going to upload this photo again taken in New York in the Times Square, and let's see how image recognition analyzes this photo. So let's do that. So let's go to our website and let's choose the photo, which was this, and let's upload it. So the file upload is successful. So if we go to our state machine and let's see the latest execution. So as you can see, our workflow now has two steps and both steps are completed successfully. This is the first step where it is getting the image and it is coming back with the labels. So let's see what the labels: spoke, adult, person, female, human, vehicles, a lot of categories in here. And if we go here, that's the input. We did not specify any output for this. So let's go to the DynamoDB table and see what labels it has stored. Label stored, and if you open that, it has the information about the name and the category. Okay, perfect. So for the next step within the workflow, which is move image to prefix, we need to provide this function with the information about the labels that Rekognition has returned, along with the confidence rating, so that it can make a call whether the image requires any further human review or whether it is clear to go. So in order to do that, let's return the event parameter from here. And deploy it. And next we will build the Lambda function to move the image to specified prefix based on the confidence rating and the labels that are returned by Rekognition. So I'm going to open up a new tab for our functions and I'm going to create a function. The name of function is move image to prefix and Python 3.14 and create function. All right, the function is now created. So what this function is supposed to do? So let's go back to our architecture diagram. So this move images to prefix Lambda function will get all the information from the store image labels Lambda function. So this will be a next step in our workflow and we'll configure that. It will have the information about the user. So remember, we get the username and the user email. It will also have the information about the image in the S3 bucket. So like S3 object key, the S3 bucket name. And it will also have the labels that the Amazon Rekognition has returned about the image. Based on all that information, what this function is going to do is it is going to check those labels against the restricted categories. And if any of the label is a restricted category, then it is going to move the image in our S3 bucket to a review prefix. So that will mean that the administrators will have to take a manual look at that image to see whether to clear it or not. On the other hand, if the image contains no restricted categories, then this move image to prefix lambda function will move that image to approved prefix in our S3 bucket. So right off the bat, as you can see, we will need to have the permissions on this S3 bucket. This lambda function needs to have permissions on this S3 bucket to move the objects. All right, so let's first add this move to prefix lambda function in our workflow. So let's go to our step function, which is image moderation workflow. I already have that open in this tab. So click on edit. So it will open up this design studio, and let's drag another AWS Lambda invoke and place it between these two steps. And again, on the right hand side, let's configure what function it will call. And that would be move image to prefix. And let's save it. All right, so the confirm role change, let's confirm that. Okay, so now this move image to prefix is a part of our workflow. And let's assign it the permissions that it needs on the S3 bucket so that it can move the images to different prefixes. So let's go to configuration, permission, and open up the execution role in a new tab. And let's add inline policy. Service is going to be S3. And the permissions are, from the read, we are going to need get object. And from the write, we are going to do a delete object. And we are also going to do put object. And let's scroll down and let's select the resource on which the permissions will be applied. So that would be the S3 bucket that we have, which stores the images that are uploaded by the users. So I do not have open it in any of the tabs. So I'm going to open up a new tab to get its ARN. Go to S3, uploaded images, go to properties, and let's copy the ARN. Add ARN, and because it needs permission on all the objects, it is going to be / and star. Add ARNs. Click on next, and let's give it a meaningful name, and let's create this policy. All right, so the policy is now created. So our lambda function move image to prefix, now it is a part of the workflow as a third step in the workflow as per the architecture diagram. And it also has required permissions to do the operations that it needs to do on this S3 bucket. Okay, so let's now move on to the code. So I'm going to close some of the tabs here. So I'm going to close the S3 one, store image labels, we don't need it anymore. Move image to prefix, execution rule I'm going to close. Okay, the rest I'll keep it open. So let's go to we are in configuration. So let's add a couple of environment variables first. So let's go to configuration environment variables, and let's add an environment variable for our restricted categories. So let's add restricted categories. In our demo, we have seen where the restricted category was only cars. I'm going to change that a little bit. I'm going to actually create a list so that it is more production-like. And for the simplicity, I'm just going to keep two values to it. So I'm going to say car, and the second value I'm going to specify is a rocket. So if the image contains any of these keywords or labels, then it should move to a review prefix. And let's define another variable, which would be the confidence rating. So we can say confidence threshold. And for now, I'm going to specify confidence threshold of 60%. So if it finds any of the restricted categories with more than the 60% threshold, then it will flag it for review. All right, so let's save this and let's go to our code. And let's start by importing the required libraries, import OS and import Boto3. And let's create the client for our S3. So we say S3 equals Boto3 client S3. All right, and now in the Lambda handler, let's read the environment variables first. So we say restricted categories and let's get the threshold. All right, so let's convert this restricted categories into a Python list. So I say try restricted labels, we can say equals except so this is if it can't decode the JSON for our restricted categories, then I'm going to raise a runtime error. That will say restricted categories must be a valid JSON. All right, and now let's read the labels that we received from our event parameter. So remember, this move image to prefix is going to get the information from store image labels. So if we go to our state machine and if we see one of the executions, so this is the state input. Right now this step doesn't have any state output, but that state output is going to be the entire event parameter, and it will have all this information for our move image to prefix to consume. So let's read labels equals event.get labels or empty list. So again, if we go back here, this entire labels object we will read. Okay, so let's define a couple of parameters. So we say send to review equals false, and matched category equals none. And let's do the comparison. So you can say for label in labels, so name, what that name is going to be. So label dot get dot name. So if you look at the object here, so we have the labels, so we will have this in our first label and we will get the name from there. And the same thing with the confidence. So we can say confidence equals label dot get confidence. So then we can do the comparison. So we can say if name, and we'll convert that into a lowercase for the comparison so that it will be case insensitive or case independent rather. So you can say if name dot lower in restricted labels and confidence is greater than the confidence threshold, send to review is true, and match category is going to be the name. Okay, so then now that we have figured out whether this threshold needs to go in review or approved, let's do a final check. So we can say if send to review workflow. I'm just going to say the image contains restricted category. So let's update this message. We can say with confidence rating of confidence which exceeds the confidence threshold of confidence threshold. So the message will say something like the image contains restricted category cars with confidence rating of, let's say, 85%, which exceeds the confidence threshold of 70%. And in fact, we can say image requires review, and else we say image does not require any reviews, no restricted categories found above the confidence threshold of. Okay, sounds good. And let's return the event. So we can just return the entire event. All right, so now let's deploy this Lambda function. All right, so the function is now deployed. So let's do a quick test before we write the code to actually move the prefix in the S3 bucket. So let's upload a couple of images. So one image will contain restricted category, and we will see in the CloudWatch log that it should say image requires review, and it will have the match category with the confidence rating. And the second image that we will upload will contain no restricted categories, and we will also check in our CloudWatch log that it will have the message that says image does not require review. So let's see if that's happening. All right, so first image that we will upload is this rocket launch image, and we'll test if the recognition correctly identifies this as a rocket and whether our move image to prefix Lambda function marks this for review. So let's do that now. All right, so let's go to our website and upload the image of the rocket and see if it filters it out. So let's go to the name. We can say and let's select the image of the rocket launch here and let's upload it. All right, so the file upload is successful. Now let's go to our state machine and see the execution. So let's go to state machine and let's exit from here. And this is the latest execution. So let's click on that. Now, as you can see, it has 3 functions or 3 steps and the execution is successful. So that seems promising. So let's go to our move image to prefix Lambda now. And let's go to monitor and click on view CloudWatch logs and open the latest logs that we have here. And as you can see, it contains this message that we printed. The image requires review. Image contains restricted categories, rocket with confidence rating of 98.41%. percentage, which exceeds the confidence ratio of 60. So that's working correctly. So now let's upload an image that doesn't contain any of our restricted categories. Let's go back to our website and and for that, I'm just going to upload this image of soccer.jpg maybe. It doesn't have any restricted categories. So let's do that and let's upload it. The image is now uploaded. So let's go to our step function to see the execution. So let's go back here, refresh it, and that's our latest execution. So let's open that. It is successful. And that's the soccer.jpg that we uploaded. So now let's go to CloudWatch logs. So same thing, move image to prefix, view CloudWatch logs, and let's open the latest CloudWatch logs. And here you go. So it does not require any review. No restricted categories have been found here with the above confidence ratio of 60%. So if we go back to our step function, the categories or the labels that it has returned is football, right? Soccer ball, clothing, footwear, shoe, sneaker, glove, sphere. So those are the categories that it returns. So none of those categories are restricted categories, which for the moment they are just car and rocket. None of these categories belong in the restricted list. So it cleared it. So it is working correctly. So now let's write the code to move the image to the proper S3 prefix. So remember, when the user uploads any image, it will be placed under the upload prefix. And now that we are making a determination, it will either move to review prefix or it will move to approved prefix. Okay, so let's do that. So let's go back to our Lambda, move image to prefix, and let's go to code. And let's write the code to move the image now. All right, so let's first read our bucket information and the file information. So here what we have read the labels, we will also read the bucket. And for the quick reference, we can actually look at the step function execution here. So bucket is under this parameter, the S3 object key is here. So let's do that. So let's say bucket equals event.get bucket, and let's say S3 object key equals event.get, and it is the S3 object key. All right. So we have the bucket information and the S3 object information now. Let's define one more variable. We can say new prefix, and for now we'll keep it blank. And here in this determination that we are doing, if the send to review is true, let's add that move to new prefix equals a review, and let's say here new prefix is going to be approved. All right, so now that we know the new prefix, now let's read the file name. So actually we can do it here. So let's get the file name. So we can say file name, and remember we have the S3 object key. So if you go to our object that we are receiving in the events parameter, so we have the entire S3 object key. It will always have the prefix of uploads, because that's how the images are uploaded in our S3 bucket when they are initially uploaded by the users. So what we need to extract is this part, this file name part, and then we will append it with either review prefix or the upload prefix. So let's do that first. So let's go back to our code, and we can say S3 object key, and we can split it based on the forward slash and get the information on the right hand side of the forward slash. So it will be S3 object key split by forward slash. So it will split into two parts and then we will get this information. All right, so let's go back to our function. And here we can say, now we have the new prefix that will have some value for new prefix. And we also have the file name here. So we can say the target key is equal to new prefix. We can do this one. We can use the F string here. Let's say new prefix. And we can say file name. So this is going to be our target key in the S3 bucket. So it will be either review and file name or approved and file name. All right, so let's write the code to move the image to the appropriate prefix now. So we can say S3 dot copy object and we can say bucket is equal to, let's see what Amazon Q has written. So bucket is equal to bucket, right? This is what we have read here. Copy source is bucket and key is the S3 object key, which is this one, the original one. And the key, the new key, is going to be the target key, which is this one. So that looks good. All right, so now once the object is moved, let's delete the object. So Q has already given the recommendation. So S3 delete object, bucket is this S3 and key is the original key. So it will get deleted from the uploads prefix and it is already moved or copied to the new prefix. So this should move the image to the appropriate prefix. All right, so now let's do one more thing. So in our event parameter, we will add this new target key. So you can say final S3 key, and we will say the target key, and we will also put the decision of send to review. So we can say event send to review is send to review. So let's put this reason in a reason variable. So we can say something like image assessment reason is, and we can just copy this entire thing. So what we are putting it in the CloudWatch logs. And why we are doing this? So let me explain as I'm typing it out. So in the next step of our workflow, we are going to send email, and in that email, we will describe why we are requiring a review, and this can directly go as the text in the email that we send to the administrators here. So it contains a restricted category with the confidence rating, so on and so forth. So I'm just going to put the image assessment reason in there, and I'm going to put that in our event parameter. Perfect. And I'm going to return the event parameter so that it is available for send to upload email Lambda function. All right, so let's deploy this. All right, the function is now deployed. So let's test it out to see if it is moving image to the correct prefix. So we will do the same thing again. So we will upload the rocket launch image that we have uploaded previously. But now what we would expect is we will see another prefix in our S3 bucket called as review, and we will see that image under the review prefix. And then we will do the same thing where we upload like that soccer.jpg, and we will see that it goes in the approved prefix or not. All right, so let's test it out. So let's go to our website and let's upload the first rocket.jpg. So we can say let's select rocket.jpg, rocket launch.jpg. Let's upload it. File upload is successful. So let's go back to our state machine and so this is our latest execution. It has succeeded. So now let's go to our S3 bucket. So we can open up a new tab, go to S3, and we should see this because we uploaded rocket launch.jpg. We should see the review prefix, and we should see only one image under that prefix. So let's click on the S3 bucket name here. And as you can see, we have uploads because those are all the old images that we have uploaded so far. And under the review prefix, we see rocket.jpg. Okay, so now we will upload an image that doesn't contain any restricted categories and check if there is a approved prefix in this S3 bucket, and we see that image under that approved prefix. So let's do the same thing. Let's go back here and let's upload an image that doesn't contain any restricted categories. So we can say Kevin Malone. And let's again upload, let's upload this Ducati image. So let's upload. File upload is successful. Let's go to our executions. And the execution is successful. And now let's go back to our S3 bucket and let's refresh it. We should see the approved prefix now, which is here, and it has that Ducati image in there. All right, so this is exciting. So we have built an image moderation app which is doing the automatic evaluation of the uploaded images, and if it finds any restricted categories in the uploaded images, it is moving it to a review prefix where a human can come in and do the further review. But if it doesn't have any restricted categories, then it is moving it to the approved prefix, reducing the load on the administrators to review every image manually. So this is great. This is exactly what we wanted to do, and our system is doing it. Now for the next steps, we are going to build a couple of Lambda functions. So first one is going to be send upload email. So this Lambda function will send out email to the admin if the image is moved under the review prefix, in saying that the submission has come in, which requires human review. And it will also send email out to the user saying that your submission is under review. On the other hand, if the image has moved under the approved prefix, it will only send out email to the user saying that their submission is live. So that's the first Lambda function that we will build, and we will use Amazon ACS for sending the emails out. And then the last Lambda function, it's a really small Lambda function. It will just mark the upload complete, which will update our record in the DynamoDB table to say that the processing is completed. Okay, so let's build the send upload email Lambda. So again, I'm going to close some of the tabs here. And let's go to our Lambda functions and let's create a function. The function name would be send upload email. Runtime again is Python, and let's create this function. So as the function is creating, this function will need the permissions to send the emails out using ACS. So we will need to provide that permission. So as soon as the function is created, we will add that permission to this function. Okay, so the function is created now. So let's go to configuration, permissions, open up the execution role in a new tab, add inline policy, and for the service, choose ACS, which is simple email service. And under the access level, under the right, let's say send email. So that's the permission that we're going to need. And I'm going to change the resource to all, and I'm going to create the permission. And let's provide the policy name, and let's create the policy. Okay, so now our Lambda function has the required permissions to send email out using ACS. There are still more configuration that needs to be done, but this is all set on the permission side. The next thing that I'm going to do is to add this Lambda function in our workflow. So again, go back to our step function and click on edit. And I'm going to drag AWS Lambda invoke and add it as a fourth step. And I'm going to choose send upload email as the function name, and I'm going to save it. Confirm the role changes. And now it's part of the workflow. So every time when this move image to prefix function executes, it will pass on the event parameter along with these three additional parameters to send upload email Lambda. So that part is done. So now let's go to Amazon ACS and let's do the configuration. So let's go to our Amazon Management Console and choose Amazon Simple Email Service. If you do not have it in recently visited, you can also search for ACS at the top and go to Simple Email Service from there. We are going to keep the Amazon ACS in the sandbox environment. So it has the daily quota of 200 emails in 24-hour period, which is plenty for our purpose. And maximum send rate is 1 email per second. Again, that is plenty for our demo purposes. So first, let's verify the email address. So let's create an identity. So click on create identity and let's say email address, because that's what we are going to verify. And for the email address, you can provide yours. I'm going to provide simple AWS tutorials at gmail.com, which is the email address of this channel. And I am going to create this identity. All right. So as soon as the identity is created, it says to verify ownership of this identity, check your inbox for the verification request and click the link provided. So let's open up the email box. And the verification email has come here. So let's open that and let's click on the verification link. And now it says, okay, the verification has been completed. So we can close this tab and go back to our ACS, refresh it, and the status is now verified. Now that we have verified our identity, we have to do a couple more verifications. So remember, we are going to send out email to the users, but we are in the sandbox environment, so we cannot really send emails out to any unverified email address. So we are going to use our inbox to receive the emails, and we will enter that verified email address when uploading any images from our website. But in order to do that, we need to verify a different email address than simpleawstutorials@gmail.com. And it is not practical to create multiple email accounts just for the testing purposes. So a nifty trick here is, and that works definitely for Gmail, where you can actually put a plus sign and anything after that will get routed to the simple AWS tutorials@gmail.com. So let me show you what I mean. So let's go to identities and let's create an identity. So let's create an identity for the administrator first. So we can say email address, and in the email address box, we can provide simple AWS tutorials plus sign and this imdemo_test_admin@gmail.com. So the emails that will go out to the administrators, they will be sent to this email address. And again, because we are in sandbox environment, we need to verify this email address. So let me create the identity, and it now says verification pending. So although our email address is simple AWS tutorials plus imdemo_test_admin@gmail.com, the verification email will come on simple AWS tutorials@gmail.com. So let's go back to our email box, and the verification email has come. So see, this is the email address that it sent email out to, imdemo.testadmin@gmail.com. So let's verify this email address. All right. And now if we go back to ACS and refresh it, it is now verified. In the similar vein, we will also verify the email address of the user. Now in the production system, this email address that the users will enter, which will be their email address. However, because we are in sandbox environment, we cannot send emails out to any external email addresses that we have not verified. So that's the reason why we are going to verify a test user email address, and we are going to use that for our demonstration purposes. So if we go back to identities, let's create the identity for the user email address, and I'm going to choose simple AWS tutorials plus imdemo@test-user@gmail.com. Create identity. Again, it says verification pending. Go back to our inbox, and the verification email has come. And if you look now, again, the to address is now imdemo@test-user.gmail.com. So although this email came to test user and this email came to test admin, they all come under the parent inbox, which is simple AWS tutorials@gmail.com. So let me verify the email for the test user. All right, so now the email is verified. If we go back and refresh it, it is now verified. So we have successfully set up our identities and verified those. Now in production environment, if you want to use the real email addresses of the users to send the emails out, we have to request a production access, which we are not going to do here. For now, these verified identities are what we are going to use to demo the image moderation capabilities. So let me refresh, everything is verified. All right. So now let's write the code for our send upload email Lambda function. So let's go back and let's add a couple of environment variables now. So click on edit, add environment variable, and the first one I'm going to add is ACS admin email. So this will be the email address that we will send emails out to if any image requires further review. So if the image is moved into the review prefix, this is the email address where we will send the email on, and that email address is this simple AWS tutorials imdemo@testadmin@gmail.com. And let's do another from address. So we can say SES from email. So this will be the email address in the from box. So if you go back here the from email address is no reply aws@amazon.com. All the emails that come from our image moderation app will have their own email address as the from address. And again, because we are in sandbox environment, we need an email address that we have already verified. So we are going to use simple AWS tutorials@gmail.com. Save it. All right, so now the permissions part is done, environment variable part is done, making sure that this function is in the workflow part, that is done. We have verified, set up and verified the identities in ACS. Now let's actually write the code. So let's go to the code tab and let's import the libraries. Import Boto3, import OS, and let's create the client for ACS. ACS equals boto3.client ACS. All right. And let's read our environment variables first. So we can say ACS admin email equals and the other one is ACS from email, which is again All right. So now let's get the recipient email. So we can say which will be event. And if you look at our execution, one of the executions, this is the step which is feeding the information, or which will feed the information to send upload email Lambda. And if you see the state output for that step, the user email is here. So you can say event user email, and let's also read the recipient name. Which will be again event, and go back to execution, the username. So we have their email address. We will enter the verified email address when we upload any images. So instead of these sort of email addresses, we will use the email address that we have verified, the test user email address, and we will upload the images from there. We have the from email, we have the email for the admin, we have the name and the address. So we'll also read the decision that our platform has taken. So whether the image is cleared or whether the image requires additional review, and that information is available here. So send to review flag. If it is false, that means the image is cleared. If it is true, then the image is flagged for further human review from an administrator. So let's read this send to review flag. So we can say image decision equals, we can say event send to review. We will get the reason as well. So image decision reason is equal to event, and that's the image assessment reason. And we will also need the final S3 key, so where the image has been uploaded. So let's read the final S3 key. Okay, so now let's do the decision making. So let's say if image decision equals false, yeah, so that means the image does not require any review. So we can say email subject is congratulations, your photo submission is now live. So email body, which can be say your photos has been approved and it is now live on our website. We do not have to give the photo URL in there. I'm just going to remove that, and I'm actually not even going to give the reason for approval. We are just going to say your photo has been approved and it's live on our website, and that is enough. Now, on the other hand, if the image decision is true, so let's go back to one of the executions. So in this case, our send to review was true because it was an image of a rocket launch containing rocket. So let's write the code for that. So we can say else, right? The email subject user, because there are two emails now that we need to send. That will be your photo submission is under review, and email body user. So Amazon Q has given the recommendation. Let's see. Hi, recipient name. Thank you for submitting your photo. Our team has reviewed your submission and decided to send it to a human for a review. That sounds not so good language when you're talking with the end users. We can just say, thanks for submitting your photo. Your submission is under review. We will revert, or we can say we will provide an update in next 48 hours. So that's usually a good practice to include the SLA in the emails that go out to the end users in these situations. And I'm not going to even mention why the review is needed, because the end users do not need to know the platform rules of what is under review and not. So I'm going to remove the last two lines, and that's all we are going to send to the user. On the other hand, now for the email subject admin, we can say photo submission needs your review, and the email body admin, let's see what Amazon Q has suggested. A new photo submission requires human review. Now these are admins are our employees, so we can be more direct and more informative in the email that goes out. So we can say it is submitted by recipient name, recipient email is fine, reason for review, and they need to know this reason. The admins need to know why something has been flagged for review. So it is good practice to include that in the email that goes out to the admins. And they also need a URL for the image, so it is good to have the URL in there as well. So I'm happy with this email content for the admin. All right, so let's actually write the code to send those emails out. So I'm actually going to do that in the same if else block. We can say ses dot send email, and source is going to be the from email, which is going to be just simple AWS tutorials at gmail.com. That's our environment variable. Destination is the recipient email, which will be the email address of the user. And again, because we are in sandbox environment, we are going to use the image demo test user identity, or this email address. And the destination is recipient email. The message has subject of email subject, which is this, and the data will be the email body, which is this. So perfect. So this email will go out. Now here we will do the same thing. So after the email subject, we can say ses dot send email, and here also we'll send the email out. So we can say this is the admin email, ses again send email, and let me copy this. And here we are going to send the email to the admin. So email subject admin, email body admin, and the to address is not going to be the recipient email, it will be the SES admin email. And then at the end, we are just going to return the entire event for our next Lambda function to consume, which is going to update that DynamoDB table. All right, so let's deploy this Lambda, and it is successfully deployed. Now I'm going to do one thing. I'm going to remove all the uploaded images from the S3 bucket and the DynamoDB table as well, so that we can have a fresh start to our testing. So I'm going to open up a new tab, go to S3, uploaded images. I'm just going to select everything and delete. Okay, so now our bucket is empty. And I'm going to do the same thing for our DynamoDB. So let's go to DynamoDB, tables, explore table items, select all, and delete. Okay, so our DynamoDB table is also empty. We cannot remove the executions here. So if you go to image moderation workflow, you really don't have an option to delete any execution. So I'm going to keep it as is. So this now gives us a fresh start for our testing effort. So remember, our user email is always going to be this one because we are in sandbox environment. So let's upload an image through our website that doesn't contain any restricted categories from our website. So let's go to our website and let's upload an image. And for the email address, it's going to be this test user email address. And let's upload a different image. Let's upload this soccer.jpg. Again, it doesn't have any restricted categories. So we should expect an email out to the user saying that their submission is live. So file upload is successful. And if you go to our S3 bucket, we see that under the upload prefix now. And let's go to executions now to see if this execution is successful. So refresh it, and it is successful. So going back to our email box, and yes, now it says your photo submission is live. So you say, hey, congratulations, Aaron, your photo is approved live on the website. And this email may go in your spam folder, because from Gmail perspective, the to address and the from address are the same. Even though our from address is simple AWS tutorials at gmail.com and to address is simple AWS tutorials plus imdemo _test _user at gmail.com. From Gmail perspective, they are the same address. So sometimes it is possible that it will go in spam, and I have specifically configured for these emails not to go in spam box. But in your case, if you don't receive the email, make sure to check the spam to see if it has come in here. Okay. So now let's upload an image that contains restricted category, and let's see if we generate two emails, one to the user and the other is to the admin. So let's start here. The email address is going to be the same because again, we are in sandbox environment. And let's upload image of this Ford Mustang, which is a car, which is one of our restricted categories. And let's see what happens. So let's upload it. File upload is successful. Let's go to our S3 bucket, and now there is a review prefix now with the Ford Mustang image. Let's go to our state machine, and this is the latest execution, and that is successful. So we should expect two emails in our inbox, and there they are. So first one is sent to the user. So imdemo _test _user, and it has their name, and it just says you're submitting a photo, your submission is under review. And the second email is sent to the administrators. So if you see the email address is imdemo test admin at gmail.com. and it says a photo submission requires human review, and the information about who did it, what's their email address, reason for review. It has a category of car with confidence rating of almost 100%, which makes sense based on the image that we uploaded. And the S3 key. So if administrators want to go and look at that image, we have the URL for that image for the admins to go and review. So that looks awesome. So for the next step, we will build this mark upload complete function, which will just enter the information in the DynamoDB table for to mark the upload process complete. So if you go to DynamoDB now, let's do that. DynamoDB, and this is our table, and we should have entries in there now. So if you explore the table items, you see entries in here. So we have the labels and we have the object keys, but it has the object key of when it was uploaded. So we need to update this object key to either the review or approved. We need to change the status from label stores to process complete. And we'll also store the reason for review. So let's do that. All right, so let me close some of the tabs here. And let me create a function. So go to Lambda, create function. The function name is going to be mark upload complete. Runtime is Python, and create function. The function is now created. So it will need the permission to update an item in our DynamoDB table. So let's first do that. So let's go to configuration, permissions, add inline policy, create inline policy, select a service, which is going to be DynamoDB. And for the access level, under right, we will need update item permission. And for the resource, let's add the ARN of our DynamoDB table. So let's go to our DynamoDB table here, tables. Let's copy the ARN. And let's add that ARN here. Click on next. And let's provide a name. And create the policy. Okay, so the policy is now created. I'm going to close this. And for our function, and if you refresh the execution role here, we do see permission for DynamoDB. So that's good. The next thing that I'm going to do is to add this function in our overall workflow. So again, if we go to our state machine, image moderation workflow, click on edit, drag AWS Lambda invoke as the last step in our workflow. And on the right side, under the API arguments, let's choose mark upload complete as the function name, save it, confirm the role changes, and it is successfully updated. So let's exit from here. I'm going to keep one of the executions open so that I can refer to the state input and the state output. So state output of this Lambda invoke is going to be the input for mark upload complete Lambda function. So it's good to have that as a reference. So coming back to mark upload complete, let's add an environment variable to store the name of our DynamoDB table. So let's go to configuration, environment variables, edit, and it will be DDL table name. And let's say the table name is image upload requests, and save it. Let's go to code, full screen, and let's start by importing the libraries. So import boto3, import OS, and we say from date time, we will actually put a date time stamp of when the process is complete. So you can say from date time import date time and let's say time zone. And let's create the DynamoDB resource. So we say DynamoDB equals boto3 dot resource. And in the Lambda handler, let's first read our environment variable. So we say TDL perfect. And let's create a table object. So we say table equals DynamoDB dot table TDL table name. Okay. Now let's read the upload ID. So upload ID is the partition key of our table that is required to update a specific item within our table. So upload ID is event.get. And if we see the execution, it's upload underscore ID. And let's get the final S3 key. And let's get the review reason or the image assessment reason. And let's also read send to review. And let's add the completed at timestamp. So we say completed at date time dot now time zone dot UTC. As a format. And let's update the table now. So we can say table dot update item. And key is going to be upload ID and update expression. So let's see what update expression is. Set final S3 key is final S3 key. Image assessment reason, send to review is send to review, completed at is completed as. And let's do a status also. So we can say status. And expression attribute name, status is status, and attribute values completed at, and attribute values. Let's add status in here. So we say status is complete. And that's about it. So let's deploy this function. And let's do an end-to-end test to see if everything is working correctly. So in order to do that, I'm going to do the purge again. So I'm going to remove all the items from the DynamoDB table and the S3 bucket. All right, so our S3 bucket is now empty. DynamoDB table is now empty. So let's upload two images one by one. One will have restricted category, the other one wouldn't. And we will again test if we get the emails correctly. And we will also go in the DynamoDB table to see if whatever we are updating as part of mark upload complete function is getting updated correctly. So let's do that. Okay, so let's test it out. So we can say Scott for the email. We have to use an email that we have verified with ACS, which is this. And for the file, I'm going to choose rocketlaunch.jpg, which is a restricted category. Rocket is one of our restricted categories. And let's upload it. File upload is successful. So let's go to our DynamoDB table and see what happened. So if we go to the DynamoDB table and let's refresh it. All right, so we have a record now for our upload. And this is the upload ID completed at content length, content type, final S3 key. So it has gone under review because it contains restricted category. And there is also a reason that we have specified why it is under review. It has all the labels that Rekognition has returned. And it also has the send to review flag, and status is now complete. And there you go. This is our end-to-end image moderation app. So we started from building our website and hosting it. We uploaded the images to our S3 bucket using a pre-signed URL. We decoupled our application components using SQS, and we built the entire image moderation workflow using step functions. And we used Amazon Rekognition to find what the image contains. And we used ACS to send the emails out. So this is our end-to-end workflow. You're more than welcome to download the code from this GitHub and use it for your own personal testing or any modification that you want to do. This concludes our series of building image moderation app from the scratch. If you liked it, please consider subscribing to the channel and give it a thumbs up. Also, let me know what your comments are in the comment section. I really appreciate it. And thank you.